the basics of Scala. What is the motivation to learn Scala? Why can't we go ahead with Java? What are the pain points with Java, in other words? One of the main pain points with Java is it is very verbose, in the sense that even to write a small program, you have to go through a lot of lines just to write a simple hello world. That is one thing. Second thing is Java is not only verbose, but it lacks a lot of modern language features which other languages have got comparatively. For example, you can do quick interpretation in Python, but you cannot do that in Java. And Java language has got inherent problems in the sense that you have to express everything as an object, and because it strictly follows the object-oriented paradigm, and the whole main function is encapsulated inside a big object, so it forces the object-oriented paradigm onto you. As a programmer, you're forced to think everything in terms of objects. The objects are actually a very poor description or modeling of real-world phenomena. So that is the second pain point with Java. On the other hand, compared to other programming languages like C and C++, Java helps you handle your business logic, and it will take care of the memory management by itself. In other words, you won't be having any core dumps, and automatic memory management is done by Java itself. So that is one big advantage which programmers get when they're doing in Java. So you are free of one task. You need not manage your own memory. The second thing is platform independence. Again, this was a big problem before Java came. In C and C++, we had this problem wherein we have to run the same program and compile it in various operating systems, and we have to deal with nuances in various operating systems. We have to configure our code and recompile it every time we change the platform. So what Java did was it had a common baseline on all platforms called the Java Virtual Machine, or JVM, and all your Java programs, your jars, your applications, they run on top of the JVM. So there is a higher level of abstraction on top of your platform. So you need not recompile Java again and again for different platforms. So Java propagated the write once, run anywhere concept. So that is one of the key breaking points of Java. So these are the advantages which Java has given us. So now what Scala wanted to do was build one step further on this. We want to build on the advantages, at the same time remove the disadvantages which are posed by Java. So one thing is retain the platform independence and the JVM dependency and automatic memory management. Second thing is we have to get rid of Java's verbosity. Meaning just to write a small business logic, we need not write like 100 lines of code. I'm sure you guys have written lots of lines of code to achieve something really trivial in Java. So that should not be the case if you're doing it in Scala. Very non-trivial business logic should be relatively easy to implement in Scala in just a few lines as compared to verbose Java. So that was one thing which Scala had in mind. The second thing was you had to get rid of the object-oriented paradigm, because like I told before, objects are very poor representation of real-world phenomena, so they cannot be used to model everything. Like for example, it's very hard to capture state in an object, because we are moving towards concurrency and parallelism. So when you are maintaining state, when two threads try to access the same variable, then you get all sorts of bugs like race conditions, concurrency issues. So that is something which Scala had to take in mind when it was designed. So they tried to introduce another programming paradigm called functional programming into the Scala arsenal. In other words, they don't force the programmer to think everything in terms of objects. So that is one more thing which Scala took into consideration. Now there was one more problem which they had to tackle. Whenever you propose a new technology, the problem is people are really resistant to change. They don't want to move to a new technology unless it is really worth it. Even if it's really worth, they have this problem of migrating whatever legacy systems they have in new technology and then run it. So that involves a lot of cost. From a non-technical perspective, from a project management perspective, let us say that you have written a bank backend service using Java, and you spend so many millions of dollars writing that, and then suddenly your developer comes and tells you that there's a new language called Scala and we can write everything and it will reduce all the maintenance cost. But the maintenance cost is really trivial compared to the cost of switching your whole application from Java to Scala. So that alone will keep people from trying Scala, because most of the legacy systems are already written in Java, and it will be very hard to migrate to Scala unless you provide some sort of backward compatibility. So what Scala had in mind is, because it is based on JVM, whatever libraries or interfaces or APIs you've written in Java, you can perfectly execute them legally in Scala programs. All you have to do is include the jar in the class path, and you can call those Java functions or classes or interfaces in Scala. So in other words, code written in Java is interoperable with code written in Scala. So this is one huge advantage which Scala had. There are other languages also which are running on top of the JVM. I mean, which had functional programming paradigms which are less verbose, but they didn't really catch on as much as Scala does, because Scala promises this backward compatibility with Java programs. So Scala had the following design goals in mind, to summarize. One, they had to retain the merits of Java like memory management, JVM dependence. Two, they had to make Java less verbose. Three, they had to maintain backward compatibility with Java code, legacy Java code. Otherwise, you won't find people who are adapting the language. So with these design goals in mind, Scala was built. Now that we are clear with Scala, this is still not a very convincing reason that Scala had these things in mind, so I have to learn Scala. So what Scala promises to me as a developer? Why should I learn Scala compared to just coding in Java? What are the features do I get as a developer when you learn Scala? Before we go to that question, you have to understand one thing about development. Most of your time is spent in maintaining, reading, and testing code. This is a very straightforward truth in software engineering. Most of your time is spent in writing, maintaining, and testing your code. You only spend like 20-30% of your time in writing new code. Maintaining it, reading it, and testing it will take up most of your software development lifecycle. So you have to optimize for that 70% of your time. So any language which is easy to read code, which is easy to test it, which is easy to maintain, is always a better choice compared to a language which doesn't ease up all these 70% of the activities. So that is where Scala addresses it. Scala code by default is more readable than any language you have ever encountered, like Java or C++ or C. To illustrate this example, I'll just show you a simple Scala code. This is a very small example of Java code, Scala code, which I've taken from the Scala website itself. So, val people array of person, val minors comma adults equals people partition age less than 18. I mean, just don't read the comments, just read the code alone. So it's relatively easy to figure out what it is. You declare people as an array of persons, person objects, and then you partition people based on a criteria. The criteria is age less than 18. Underscore is your Java equivalent of this. We'll be looking at the details later on. So what this does is it partitions the people list into two lists, where one list is list of people whose age is less than 18. Other list is list of people whose age is greater than 18. So this code is very readable and easier to understand than your equivalent Java code. The same thing they have done in Java. So they've declared a list of people. The Java version you guys must understand because you guys already know Java. You have to declare minors, adults, or the initial sublists before itself, and then you iterate through it. If person age is less than 18, all that you have business logic here. So let us say tomorrow your requirement changes, like which is typically the case in big data. They say that you have to partition a large list not based on age but based on some other criteria. You have to this happens typically when you join a project which already midway through. First you have to understand where the age processing takes place. You have to go to that function and then change it. But in the case of Scala, that is not the case. You can easily read it and find out, okay, this is where it's happening, and then just a one-line change. So this is the kind of readability I'm talking about.